Here is another multiplication cryptarithm. A 6-digit number A, B, C, D, E, F is being multiplied with 3, and we are given that the product is also a 6-digit number B, C, D, E, F, A. So here B, C, D, E, F is preceded by an A, and here B, C, D, E, F appears as it is, followed by an A. So which digit should we start enumerating first? We can do something similar to what we did in the previous problem. In the previous problem we had a 4-digit number which when multiplied by 4 continued to yield a 4-digit product, and this fact allowed us to restrict the value of the value that letter A can take, because we saw that A cannot represent a digit greater than or equal to 3, because if it did represent a digit greater than or equal to 3, then the product of this number with 4 would have 5 digits, not 4 digits. So this fact allowed us to restrict the values that the letter A could represent to just 1 or 2. We can do something similar here. Since we know that the product of this 6-digit number and 3 continues to be a 6-digit number, we can restrict the values that this letter A can represent. For example, if the letter A represented the digit 4, then when computing the result of this multiplication operation, somewhere towards the end we would multiply this number 3 with a 4, and that would give us 12, and then we would add a carry. If at all there is a carry from the previous operation, we would add that in, and the result would at least be a 12. Now how would we write that 12? We would write a 2 in the in this column, and then we would have an extra 1 in the next column. So the result would be a 7-digit number, not a 6-digit number. So we can say that if we put A to be equal to any digit greater than or equal to 4, then we would end up with at least a 7-digit product. So we would have 7 digits in the product, not 6 digits. So this allows us to restrict the values that letter A can represent to 1 or 2 or 3. A cannot be a 0 because we cannot have leading zeros in our numbers. So there are 3 possible values that A can take. So let's look at each of these possibilities. Suppose A is 1. Let's see if we can try to figure out the values that the other letters would represent in this case. So if A was 1, we could rewrite this multiplication operation as 1 B C D E F multiplied by 3 is equal to B C D E F followed by a 1. Now, does this help us in any way? Can we move to the next step? Can we figure out the value for some other letter by looking at this multiplication operation? Well, let's look at the product of 3 and F over here. When we multiply this number with 3, the first thing we'll do is we'll multiply 3 with F. Now, when we multiply 3 with F, we would get a number which would have a 1 in the units place. That's something we know. So if you recall the multiplication table for 3, we know that there's only one number that 3 could be multiplied with, and that is 7, whose such that the product of 3 and that number, or the product of 3 and that 7, would be some number. In this case it would be 21, which would have a 1 in the units place. There is no other single digit number that 3 can be multiplied with which would yield a 1 in the units place. So this means to have a 1 here, f must be 7. So let's put f equal to 7 over here. We get 1bc de 7 times 3, and we would have a 1 here, and since f was set to be 7, we'll put a 7 here, and then we still continue to have these letters B, C, D and E. So if 3 7s are 21, we would have a carry of 2 into the next column. Now 3 times this letter E plus that 2 would yield a 7 in the would yield a number which would have a 7 in the units place. So which multiple of 3 when added to a 2 gives rise to a number with a 7 in the units place? Well, to have a 7 in the units place, the multiple of 3 that we're talking about should have a 5 in the units place, because if it had a 5 in the units place, then when we add a 2 to it, the result would have a 7 in the units place. So which multiple of 3 has a 5 in the units place? Well, 3 times 5 is 15, and 15 has a 5 in the units place. So if E was 5, then 3 times 5 would be 15. 15 plus 2 would be 17, so that would produce a 7 in this column and a 1 that would be carried over. So this doesn't lead to any contradiction over here. So let's put E equal to 5, and let's rewrite this with that, substituting E by 5. 1bc d 5 7 times 3 yields 1 7 5 D, C and B. So again 3 7s are 21, 3 5s are 15, 15 plus 2 is 17. And now let's look at this column. Let me write the multiplication operation outside over here. 3 times D plus 1 results in a number which has a 5 in the units place. So to have a 5 in the units place, 3 times this digit D should be a number that has a 4 in the units place, because if it had a 4 in the units place, then when we add a 1 to it, we would end up with a number that had a 5 in the units place. So in the multiplication of table of 3, what number when multiplied by 3 produces a 4 in the units place? Well, 3 8s are 24, and that's the only single digit number you can multiply 3 with to get a 4 in the units place. So 3 8s are 24, and so let's try putting D equal to 8, so that we get 24 here. 3 times 8 is 24. 24 plus 1 would be 25. So we write a 5 here and we carry a 2 into the next column. So let's substitute D by 8. We get 1 BC 857 multiplied by 3, producing BC 8571. So again, writing the carries as they are from here. So 3 8s are 24, 24 plus 1 is 25. We carry a 2 forward here and we write a 5 here. Now 3 times C should be a number such that if you add a 2 to that number, you get an 8 in the units place. This means 3 times C should be some number that has a 6 in the units place, because if it had a 6 in the units place, when we add 2 to it, it would result in a number that had an 8 in the units place. So in the multiplication table for 3, what number should we multiply by 3 to get a 6 in the units place? Well, C can be 2, for example. 3 2s are 6. And in fact, that's the only possible option if you want a 6 in the units place. So let's put C equal to 2. If you put C equal to 2, we get 1B 2 857 times 3. We write this multiplication operation over here, and in the product we get B followed by C, which C is 2, and 8571. Now we have only one letter left, and that's B. Let's figure out what it is. So I'm just going to copy the carries over as they are. So we have a 2 1 2, we have a 2, a 1 and a 2. So let's directly move to this particular step. We have 3 times 2, which is 6. 6 plus 2 is 8. So we've written an 8 here. Then we are going to multiply 3 with this letter B, and the result is going to have a 2 in the units place. So which single digit number when multiplied by 3 produces a result that has a 2 in the units place? Well, 3 4s are 12, right? So 3 when multiplied by 4 produces a 2 in the units place and a carry of 1. Now 3 times 1 would be a 3, and 3 plus 1 would be a 4, and so we would need to write a 4 over here. And that is in fact consistent because we just put B equal to 4 here. 3 times 4 was 12, and that resulted in this B also being 4, which is perfectly consistent. So in fact, we found a solution to the problem, which is 142,857 when multiplied by 3 produces a result that is 428,571. So this is one possible solution to our cryptarithm. But remember, this is the solution we get when we put A equal to 1, and there are other possible values that we can substitute for A. So we should check whether those other values result in additional solutions. So let's put A equal to 2. Case 2 is when A is equal to 2. So instead of 1BCDEF being multiplied by 3, we would get 2BCDEF being multiplied by a 3, and the result would be BCDEF followed by a 2. BCDEF. Now if A is equal to 2, what should be the value of F so that when 3 is multiplied by F, we get a 2 in the units place? Well, F should be equal to 4, because it's when we multiply 3 by 4 that we get 12, and 12 has a 2 in the units place. So let's put F equal to 4. We get 2BCDE4 multiplied by 3, resulting in a product BCDEF, but F is 4 here, followed by a 2. Now 3 4s are 12, so we get a carry of 1 in the next column. Now when 3 is multiplied by this digit E, we get a number such that if we add 1 to that number, we are going to get a 4. This means when we multiply 3 with this digit E, we should have got a number that had a 3 in the units place, so that when we add a 1 to it, we get a 4 in the units place. So which number when multiplied by 3 yields a 3 in the units place? Well, 3 1s are 3. So let's put e equal to 1 and we get 2bc d14 multiplied by 3, producing a result bcd 142. Now let me write the carries again. Now let's see if we can find the value of d. 3 times 1 plus 1 is 4. So there's no carryover from this column. So when we multiply 3 with a d, we should get a number that has a 1 in the units place. That means d must be 7, because 3 times 7 is 21. So if we substitute d by 7, we get 2bc 714 multiplied by 3, producing a result bc d, which is 7142. And again, if we put the carries over here, we get 3 sevens are 21, so we have a 1 over here and a 2 that is carried over into the next column. Now 3 times c plus 2 should be a number that has a 7 in the units place. This is a little messy, so let me rewrite this properly. So 2bc 714 is being multiplied by 3. 3 fours are 12. 3 ones are 3 plus 1 is 4. 3 sevens are 21. Now 3 times c plus this 2 should be a number which has a 7 in the units place. 3 times c plus 2 should be a number that has a 7 in the units place. This means 3 times c should be a number that has a 5 in the units place, because if it had a 5 in the units place, then when we add a 2 to that number, we get a 7 in the units place. So let's put c equal to 5. We get 2b5 714 multiplied by 3. 3 times 4 is 12. 3 times 7 is 21. 3 times 5 is 15 plus 2 is 17. And since c was 5, I should replace this c by a 5 here and a b here. And we need to find the value of this letter b. So 3 5s are 15 plus 2 is 17. 3 times b plus 1 should be a number that ends that has a 5 in the units place. So if 3 times b had a 5 in the units place, if 3 times b plus 1 had a 5 in the units place, that means 3 times b must be some number which had a 4 in the units place. And what single digit number when multiplied by 3 yields a product that has a 4 in the units place? Well, b is 8. 3 8s are 24. So let's substitute b by 8. We get 285,714 times 3. 3 4s are 12. 3 1s are 3 plus 1 is 4. 3 7s are 21. 3 5s are 15 plus 2 is 17. 3 8s are 24 plus 1 is 25. 3 2s are 6. 6 plus 2 is 8. So we get 857,142 as the result. And this is consistent with the result over here, because we just put b is equal to 8 over here. And we saw that this b got replaced by an 8. So this is another solution to our cryptarithm. With a equal to 1, we got one solution. With a equal to 2, we got another solution. Now let's look at the third possible value for a, which is 3. So if a is 3, case 3 is when a is 3. And when a is 3, by substituting 3 in the original problem, we get 3bcdef times 3. We get 3bcdef times 3. And the result, we have bcdef followed by a. But a is 3 here, so we get bcdef followed by a 3. So this is just the original problem. A, B, C, D, E, F times 3 gives B, C, D, E, F followed by an A, but we have substituted A by 3. Now let's look at the other letters. 3 multiplied by F should be some letter that has a 3 in the units place. And we know that 3 ones are 3. 3 times 1 is 3. So we could substitute F by 1 and proceed the same way as we've been doing so far. But I'm going to show you a faster way to conclude this particular case. We know that this is a 6-digit number and we are multiplying it with a 3 and we are still getting a 6-digit number. Now we also know that the leading digit here is a 3. So the product of 3 and this number must be at least 900,000. This 3 multiplied by this 3 is going to lead to a 9 in the leading digit over here, because if it led to any number that was more than 9, that is to 10 or more, then we would have an extra digit over here. We do have exactly 6 digits in the product. We don't have an extra digit here. So that means this 3 multiplied by this 3 must yield a 9 over here. So B must be a 9. That is, this letter must be representing a 9. So let's see what happens if we substitute B by 9. 3 9 C D E F, and we kind of determined that F would be 1, but let's ignore that for now because we are not going to need it. B is 9, so we have 9 C D E F 3. So we know that 3 times 3, the last multiplication step, 3 multiplied by 3 plus any carryover from the previous column should be a 9. In fact, there should be no carryover from the previous column, because if there was a carryover from the previous column, then that carry would get added to 9, leading to a number that was 10 or more, which would result in an extra digit. So we can conclude from this that the carryover from the previous multiplication, that is the multiplication of this 3 with this previous letter, should have resulted in no carry at all into the last column. It should have been a 0. The carry should have been a 0. But when 3 is multiplied by 9, the carry cannot be a 0, because the product of 3 and 9 is 27, and if we add to 27 a carry from the previous column over here, then the result is going to be at least 27, if not more. So there will definitely be a carry into the last column. But if there is a carry into the last column, then 3 times 3 is 9, and 9 plus that carry would be 10 or more, leading to an extra digit in the product. And we know that's not the case. That shouldn't happen because we are given that the product has exactly 6 digits. So we have a contradiction. We have 3 times 3 being 9, that is b being 9 over here. But if b is 9, then we get a carryover when 3 was multiplied by 9 over here. And if we get a carryover here, then we get more than 6 digits over here in the result. We get at least 7 digits. So that's a problem because we have an inconsistency here. So really a cannot be a 3. This means the two solutions, the two viable solutions to this cryptarithm are 142,857 times 3, whatever product that results in, and 285,714 times 3, with the product being 857,142. These are the two solutions to this cryptarithm.